Okay, so homework 1.3, question 14 is just a quadratic inequality graph question like we've done a few times now in the homework. Now we're kind of doing this a little bit ahead of schedule, okay, so we will kind of come back to this at various points in higher, so don't panic if you're struggling with these questions too much. It's something that, had we had a little bit more time at the end of fourth year, we might have done a little bit more work of, so that's why these questions are in the homework. But this one talks you through it quite well. It breaks down the question for you quite well. But quadratics is always a notoriously difficult question at National 5, so we're just going to take our time with this. First part of the question just asks us to solve the trinomial. So I'm doing a slightly different example, but you're going to follow the exact same steps for question 14 in the homework. So the one in the homework is 2x squared plus x minus 1. The one I'm going to do with you is 3x squared minus 2x minus 1 equals 0. So it's a very, very similar question and you're going to need all the same steps. Easiest way to solve a quadratic that's equal to 0, either factorise or use the formula. Formula might be awkward here. If it's a paper 1 question, you might have a bit of number crunching to do. You think about how big and complicated the quadratic formula can sometimes be. So hopefully we can factorise this nice and easily and then that will be quicker. 3x squared, the only two things that multiply together to give you 3x squared are 3x and x. So the start of our brackets is very straightforward, although it looks like it's a more complicated trinomial. Second, the end of the brackets, the two numbers at the end of the brackets are going to have to multiply to give me minus 1. So it has to be 1 and 1, because those are the only numbers that multiply to give me 1. And 1's going to be a plus and 1's going to be a minus. So the only thing that we've still got to do is work out which one's a plus and which one's a minus. I'm aiming for minus 2, so I really want minus 3x and then plus 1x, because that would give me minus 2x altogether. So those little rainbows sometimes help to work that out. Now, we're asked to solve the equation. We're not just asked to factorise it. So from the two brackets, that then tells us that 3x plus 1 is 0, or x minus 1 is 0. So that means that 3x would be negative 1, which means that x would be negative a third, and x would be 1. Now, what you've maybe not contemplated yet, but when we get to part C, this is important, is if we solve an equation equal to 0, remember that tells us where it crosses the x-axis. It crosses the x-axis when y is 0. So our y-coordinates are 0 here, that's effectively what we've just worked out, and our x-coordinates are the two numbers we've got, which are minus a third and 1. So that's a starting point for us. We also know by looking at the equation, it's a positive x squared, so it's going to have a minimum turning point. It's going to be a happy face, but we'll get to that when we do part C. Part B, f of x equals 3x squared minus 2x minus 1. Write down the value of f of 0. So f of x and y are basically the same thing. So we're working out what happens when x is 0. So we're going to get the coordinate 0 something, i.e. this is going to be where it crosses the y-axis. So f of 0 just means that everywhere there's currently an x, we're going to put a 0. So I've got 3 times 0 squared, minus 2 times 0, minus 1. 3 times 0 squared is 0, 2 times 0 is 0, and then I've got minus 1, which just gives me the answer negative 1. So the value is negative 1, or if we turn that into a coordinate to help us with part C, that's going to be 0, negative 1. So I've now got these 3 coordinates that I'm going to be using when I do part C, where it's asking me to use the answers to A and B to sketch the graph. Now your graph's going to be a heck of a lot neater than mine is. Still not found a straight line tool on this. So what have we got? We have got that it crosses the x-axis at minus a third 0 and at 1 0. Now although you don't need to have a totally accurate counting boxes graph, you want it to be roughly a decent scale. So if I make that 1 0, then this is going to be minus a third 0 there. Okay, that would roughly be a decent enough scale. And we also know it crosses the y-axis at negative 1, so I would probably put that down here, and I'm going to write that on this side, which you'll understand why in a minute. And we know that it's a minimum turning point. Now, I've not written this down, but the question asks us to find where the minimum turning point is, to get the coordinates. Hopefully remember from National 5 that the minimum turning point is on the axis of symmetry. So we're looking for the halfway point of this graph, the axis of symmetry, which of course should be a straight line if I could draw it accurately. So we're trying to find the halfway distance between 1 and minus a third. So we're trying to find where's halfway between 1 and minus a third. Okay? Now, the distance between 1 and minus a third is 4/3. Okay? Which means that the halfway distance, we're going 2/3 back or 2/3 forward. Okay, but either way, the coordinate is going to be a third something. Okay, there are other ways you've maybe been shown how to do that. Okay, so one of the ways that I often teach my pupils to do it is to add the two coordinates together. So I've got 1 plus minus a third and divide it by 2. So 1 plus minus a third is 1 take away a third. 1 take away a third is 2/3. 2/3 divided by 2 is the same as 2/3 is obviously 1/3. Sorry, momentary brain freeze there. Okay, or you might prefer to think of it actually as 2/3 times a half, if you prefer to do it that way. So kind of the divide becomes a times, the second fraction turns upside down effectively, you might have heard that phrase, and that's, you would have 2/6, which would be a third. So our x coordinate is a third, and we would need to work out our y coordinate. We'll worry about what our y coordinate is in a second. I'm just going to draw the curve. It's got to go through all those points. Now, you might ask me, Mrs. Knack, how do you know that that minimum turning point is below that -1, 0? Well, think about what the phrase is. We've just called it the minimum turning point. Okay, it's the lowest point on the graph, so it has to be below -1, 0. So I can draw it, even though I don't know what the y coordinate is, but we're going to work that out now. The equation of the graph was 3x squared minus 2x minus 1. But we know that at this coordinate here that we're looking at, x is a third. So we've got 3 times a third squared minus 2 times a third minus 1. It's not the neatest here, but we'll get the general idea. A third squared is just a 9th, remember. Excuse me. And then minus 2/3 minus 1. So 3 times a 9th is 3/9, which is a third. A third minus 2/3 minus 1. Notice I'm doing all this without a calculator in case it came up in paper 1. A third take away 2/3 is minus a third. Minus a third, take away another 1 would be minus 1 1/3 or minus 4/3. And I always prefer to go for a top-heavy fraction. So the coordinate of the turning point is minus 4/3. Now, it's not actually important for part D, but it was asked of us in part C, so we needed to have it. Part D, use the graph to solve 3x squared minus 2x minus 1 is less than or equal to 0. So we want to see everywhere on this graph that is less than or equal to 0. So remember, this is the line where it's equal to 0. So everything that's less than or equal to 0 is everything under the x-axis. So it's everything between minus a third and 1. So the way we would answer that is it's for everything where x is less than or equal to, because remember it's allowed to equal 0, so it would be allowed to equal 1, so on that point there is okay. But it's got to be bigger than, greater than or equal to, so I can add that at this side, greater than or equal to minus a third. And you can write that as two separate inequalities. So you can say x is less than or equal to 1, but greater than or equal to minus a third. Or you can write it as one single inequality. It doesn't really matter. Hopefully that's helped, but if not, let me know.